Welcome to the second movie of KiMoPack. In this movie I'm going to introduce you how to open files and how to use Jupyter notebooks in general. In the first movie we have installed KiMoPack using PyPy and installed Python, and we have copied our workflow tools, in this case the raw plotting, into the project folder. Afterwards we have renamed this workflow tool to something which is local for the project. Now, if you open up KiMoPack the first time, you will find that there is first an importing function, and we need to run this cell. This you can do either by pressing run or by pressing Ctrl and Enter after you have activated it. And you will note that it first shows you what version, then from where this was loaded, because you can actually run that locally or you can import it from many different places, and it shows you the working folder. The working folder is important because this would enable you to load files directly from the folder. If they are somewhere in a different location, you have to give the relative path, or simplified, use the GUI. Using the GUI opens up a selection, and you can select where is your data. For example, here I select CR file. Once you have done that successfully, and this simply means that there is no error, then the file is open, and during the import you create an TA object. This TA object, no, I just named it also TA with small letters. This contains everything of your file. It contains all the parameters, and it also contains all the functions. For example, all the plotting functions, and functions in KiMoPack start with a big letter. Everything will start with a small letter, is a parameter. Everything what is a function starts with a big letter. For example, all the plotting tools start with P. I press Tab, and the Jupyter notebook shows me what different types of plotting functions I have. I can plot the fit output, I plot raw, coming to that, and I can plot interactive. So a quick first look on the data, interactive plotting, and I get a plot window. Now I can make this the right size. So I get the plot window, and I can now click in the plot window to see different places. You will note that there are spikes in the data, which really make stuff very difficult to see, and that there's different arrival times. If I click through different wavelengths, you see that this is shifting. So classically, the first thing we do, we would correct for a few of those cases. And that's why this is usually the first cell you see. By using the word recent, you load the same file again. Very useful. Otherwise, you can type GUI here to open a fresh one. I filter values out using bad values. Everything that is above the threshold is deleted. And then I call the job correction. And afterwards, I correct for the background. These are usually standard values. That's why I don't change that. If you have run a job correction before, the file will also use the old job correction. If you want to run that manually, you can do that at any time. And then you come into the job correction module. In the job correction module, you can select different intensities to make it visible where you want to correct for. Accept the values. Do a quick guess of where your wavefront, where your arrival time front is. Usually that's good enough. You get an fourth order polynomial. You like that one, or repeat the work, select where is your time 0, and say save, and you have corrected. Now we can of course go a step further and continue with interaction, and I often create new cells just to keep in the flow and going down. However, you could also use cells above. If you would like to know what options different functions have, in Python classically, well, for example, what correct chirp, use the tab to complete. You could type a question mark, and it shows you all different options that you can use in the function, plus docstring. However, this is usually very difficult to read. That's why I created this read the docs module, where you find for under the function index on the left side you find all of the functions, and you can read, for example, here what you had correct chirp. I could read all of the options, and you can see that the options are extensively explained, how they work, how do you choose, and also there's examples how to use a function. After correcting the chirp, the background and similar parts, we could again start to plot. We use our interactive plot for one more time. And you see that these spikes are gone. But you still have a region where, for example, we have pump scatter, which shows that there is parameters you would like to set. Now at this stage, I typically do this for once for the project and then keep these values for the rest. One would set, for example, what are interesting wavelengths to look at. You can change this at any time, but usually you set them once. Here I set a standard just starting at 360 going to 850 in 50 nanometer steps. There's a few other parameters, which values or what they do, you can look up in the documentation. Classically, one sets the time limit. I want to plot from there to there. If you leave that free, it takes the maximum. You set the side corners, and you can scatter cut where you suppress the scattering. Lastly, instead of using the interactive plot functions, which I could do easily again, I can use plot raw, which generates 4 different plots. It generates a matrix. It generates the kinetics, the kinetics at the wavelengths I have selected. So the wavelengths I have written here. It generates the spectra with the slice where there's the scattering, and it generates the SVD of the data, where you can, for example, look how many different components you have, and how many, what are the typical times, and what are the typical spectra. If you want to use just one, you can use the options, for example, just using 2 generates only one of the plots. Classically, you could now save the project, save just the plots. I really like to use this option save PowerPoint, which generates the plots and afterwards generates a file. All data was saved into the folder in my work folder, which is here. So where the data is now a subfolder called result figures, where is the plots and a PowerPoint file, which could be changed to be a PNG file or a PDF file or something, which is simply generating me an overlook where I present the data. You can do the same later when you have the fit results, and that's just a documentation which you can take for your next meeting to discuss with your colleagues. Thanks for your attention.